Nosso próximo palestrante é Services Engineer da MPN. Ele já foi instrutor no programa de certificação da Universidade de Washington. Olha o nível do bagulho. Certificação da Universidade de Washington. E ele é o organizador da JS, que deve ser um grande evento de JavaScript. Claro, não tão grande quanto o nosso, na verdade. Mas é o cara que faz lá em Seattle. Por favor, venha pra cá, Jeff Lembeck. Uma salva de palmas pra ele, vai. Aê! Welcome.
Yeah. Okay. Holy shit, this crowd is huge. My parents are never gonna believe this, so I'm gonna take a picture of this, and then they're gonna be like, "You took that online," so I'm gonna do this and like, and then my 3-year-old daughter. This is her little stuffed animal that she sent with me on this trip to let her know. So I'm gonna do this real quick and be like, this guy is talking to this whole crowd. All right. I'm Jeff Lembeck. I'm one of the service engineers at NPM. This is my Twitter handle and my name. And also, if you want the slides and the presenter notes and whatnot while I'm talking, that's where you can get it. It's just a PDF that's there. So my Twitter handle's there, so in case you want to yell at me or just send me heaps of infinite praise that I can look at afterward, that'd be cool. For more unnecessary introduction, I'm from Seattle, and I'm incredibly from Seattle. I'm an extremely Seattle person, and so I drew this picture of Seattle, which is super accurate. That don't Google it. That's what Seattle looks like. But this is a picture of Seattle from the before time. You see, today I'm going to tell you a story. It's a story about a hero. So let's go. The world is veiled in darkness. Dependencies are inconsistent. Builds are slow. Version numbers matter not. The people wait. Their only hope, a prophecy. When dependency hell has plagued your JavaScript project, a tool will come. And after a long journey, some programmers arrive, each holding a pretty loaded metaphor for a technical talk. I give you package quest. So, our story begins not so long ago when you, maybe, our hero developer, are given a mission. Build a great website to honor your gods of user. Your gods are numerous and vengeful and will not tolerate an experience less than pristine. Your bosses, the masters of C-Team, are demanding that you appease the gods quickly so as they can be granted riches in this life and the next. This task sounds grueling. Building each part of a website from nothing involves strong magic, patience, and time. And in a world in which each of these items are scarce, we need something to help us, something to guide us, something to give us the pieces that leave us less exposed to the cruel, monstrous insects that anger our user gods. There is a place that is spoken of that was used long ago, after the great programming war when the Dark Ages came into place. All of our help and hopes were destroyed, and speaking of this location and the tool to get there was forbidden. But word of mouth has passed on from generation to generation, and you, our hero, will search out to find our land of desires, the registry. The only thing we know is that to enter the registry, there is a talk of a tool, a magical weapon to destroy dependency hell that was forged by sorceresses of colorful hair. This tool survived multiple iterations and was faster and more powerful than anybody could have imagined. This tool, called NPM. NPM was cleanly broken apart by the sorceresses, hey, in case the day ever came where it needed to be built again. So I bring you my story. Book 1, Chapter 1. According to the old documentation found in the ruins of GitHub, our magical tool requires the help of 3 companions. Shishigami, the forest spirit. Pacote, the master of packages. And registry client, a smuggler that can give you a special passcode to enter the registry. Each of these, when brought to the sorceresses of colorful hair, can be forged together by the light of JavaScript to create the NPM tool. And so, hero, to begin, we visit Shishigami, the creator of the dependency tree. The forest spirit's job is to piece together exactly what you need from your install. It scours through your list of package demands and also through what you have already installed and puts together an ideal tree, a perfect structure of your dependencies, so all your needs will be served. It achieves this by first reading your local package tree. It does this by combing through your node modules folder. Then it reads your package lock JSON file to make sure that the tree built from your node modules directory matches the tree from your package lock. After that, it is time to get the metadata for each missing package. At this point, Shishigami will call upon pacote. Pacote's role within building a dependency tree is to reach out to the registry to get information about each package needed to be installed. According to the documented scriptures of pacote, this information will be delivered via Corgi doc. Side note, I searched on Google for a Corgi doc, and this came up, and how do you not use that picture? So Corgi doc is not a small and cute dog as represented here, though that would be so great, but a very small piece of metadata that lets the tree worker know which versions of the package are available in the registry. Once this metadata is in place, the tree is normalized. Shishigami then puts together the ideal tree and calculates the difference between that and the tree that has been put together from the package lock and the metadata. The difference is where packages are moved, removed, fetched, and installed. Shishigami is located within the NPM repository. If you go there and speak its name, it joins your party. Book 1, Chapter 2. Now that you have Shishigami, you will need pacote. Pacote is the master of packages and comes equipped with their own caching system, Kakash. Kakash is pacote's nearly endless pack of fun. It is a key value storage system written in Node.js that is immensely fast. What it does best is get you the correct data quickly. It does this with great concurrency, incredible fault tolerance, support for SHA-1 and 512, and data consistency that notices if its data is corrupted, either from a man-in-the-middle attack or a change on your own machine. During installation with the NPM tool, Kakash stores the package data in this folder, your home directory, hidden directory, npm _ Kakash. Anyway, in case you want to look later. If the content is unavailable in the cache, pacote uses make fetch happen to fetch the package. Make fetch happen is a wrapper for node fetch, a Node.js implementation of the browser's window.fetch. Make fetch happen tacks on HTTP cache support, request pooling, and several more features to make it very easy to use and very fast. Its caching system relies upon Kakash. Because pacote knows that make fetch happen uses Kakash as its caching system, when pacote is asked to fetch a package, it can use Kakash directly to get any data that it would use make fetch happen to request before it uses make fetch happen to get the package. So first, it asks Kakash, do you know about the package I need? Many times, Kakash says yes, but when it says no, pacote can use make fetch happen to go out and grab the package. Then, when make fetch happen returns the package, it can be stored inside of Kakash for pacote to get next time. Pacote also provides an extractor to unwrap the packages that it is installing. Packages come from the registry in the form of tarball, and pacote understands how to make this into executable JavaScript for your consumption by unpacking the contents and placing that code accordingly. And as mentioned before, when dealing with Shishigami, Pacote is capable of reaching out to the registry to grab the necessary metadata to understand just what packages you need. That metadata helps Shishigami by letting it know which versions the registry has of the packages you need, so it can build the dependency tree perfectly. Pacote is largely the workhorse of the NPM tool, and it lives in the repository on GitHub, where you can find her. You ask, she eagerly joins your party. Book 1, Chapter 3. The last and final spirit that you need to build a tool is registry client. Much like other API clients, the registry client is a wrapper around an external API. Registry client allows you to talk to the registry for most anything revolving around your account and management of things you own. This includes changing ownership of packages, publishing and unpublishing packages, adding and removing members to and from your orgs, and in this case, authentication. When you use the registry client for authentication, it asks you for your username, password, and email address. Have you ever typed npm login? That's what I'm talking about. Then it takes to the registry and returns with an authentication token. When you authenticate, the registry remembers your token and you store it into your npm rc file. That token will be useful when you and Pacote use the tool to go get your packages. You find registry client lurking behind a corner on GitHub in the npm repository. You pass it a note saying, "Will you join my party?" It nods its head and follows you. Book 1, Chapter 4. Man, this is long. Pacote, Shishigami, and the registry client have guided you to npm Inc., home of the sorceresses of brightly colored hair. They introduce themselves and walk you and your new party members to the installer. The installer is cold, it is mechanical, it is linear, it has a beginning and ending. It's a picture from Chrono Trigger. Everything else is a step along the way. Within the realms of the installer, they forge together the spirits of your party members to be called upon any time you desire. Their magic is strong, and they have added to the tool the ability to increase its level, to learn new skills and talents along the way, while simultaneously making the quest to obtain your packages smoother. You can do this by telling the tool to install itself. CLI, 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 they chant. The tool is yours. Go, log in, then install. Book 2, Chapter 1. With the mission to forge the CLI complete, we turn to our map to see where the path forward leads. All signs point to the great registry, registry.npmjs.org. Let us make the journey. You start your quest at the land of Terminal Point. First, we log in. You pull out your CLI tool. You speak onto it. npm, login. The spirit of the registry client emerges. Username, J. Lembeck. Password, a very good password probably, that I don't use anywhere else, I promise. Email, jeff@npmjs.com. And with that, you are whisked away. Sorry. We ride the road of the great network to the first destination on this quest. Fastly. Haha, this thing works. She goes by the name of Fastly. Fastly is a CDN class who specializes in speed. She and her sisters, all with the same name and same personality, just different locations, like Officer Jenny or Nurse Joy in Pokemon, niche audience here, spread the globe and position themselves in ways so you'll get them far more quickly than if you were to reach out to just one part of the world. She handles the cache for packages, and if you approach her with the name of the package you are looking for, she will do her best to get it for you. Just remember, she has the right to refuse service to anyone, so do not attempt to backdoor, spam, or crawl too aggressively, Or you will arrive with a shut door with 412, precondition failed, written on it. And no, seriously, I will write that right into that VCL code. Do not make me do that. Unbeknownst to many, Fastly also provides traffic routing. She handles all requests to the registry and will forward them along to where they need to go. How she does her work is largely based upon two things, her cache and a light routing layer written in VCL. Fastly looks at you. What brings you here? Authentication. Let me see. Right this way. Fastly guides you to a path. Ahead lies foyer. Go. You are whisked away to the next destination. Book 2, Chapter 2. Foyer operates as the entry point to the NPM registry. Information about packages, users, orgs, teams, and any modification to those things must first go through Foyer. Foyer also handles the path to authentication. You and registry client knock on the doors. From behind the walls you hear, "What is your purpose?" I would like to log in. "Hand me your credentials." One moment. The guard behind the door calls for a messenger, the NPM auth WS client, and tells them to take this information and be on their way. Side note, it's really good that Carol gave the talk right before this because this is like a microservices smorgasbord. Anyway, Book 2, Chapter 3. NPM auth WS is a gatekeeper for proving who you are and where you can go. She is quiet and only speaks with messengers from behind the doors of the foyer. NPM auth WS serves two purposes in the registry, authentication and authorization. Authentication being when you prove who you are. Authorization being when you are checked to see if you have access to something. In this case, the client is headed to NPM auth WS on behalf of your need for authentication. NPM auth WS is used for multiple kinds of login, including if you run your own NPM private registry and the public registry. In this case, we're talking to the public registry, for example. NPM auth WS chooses the specific client for the authentication type. An NPM auth WS client hands your credentials to them. The NPM OAuth user API, who then reaches out to the Synecdoche API. The Synecdoche API is the glue that binds together the two beholders of truth, user ACL2 and the payments API. Check out his jewels, those are sweet. Its API acts as a proxy for user ACL2, and when requests come through that gather or change information about payment, it also makes a call to the payments API. As the NPM OAuth user API reaches out to login, the request is proxied through Synecdoche API to user ACL2. User ACL2 is the grand beholder of truth. If any changes are made to any accounts, it is written by user ACL2, and then that information is sent elsewhere via NSQ messages. Any of the calls to Foyer from the registry client that were mentioned earlier that involved changing teams, organizations, or users, they would have been forwarded through to user ACL2. In this case, logging in also happens via user ACL2. Assigning packages to teams, that happens in user ACL2. And most relevant for this story, well, logging in. The NPM OAuth user API passes the credentials to user ACL2 for your logging in, and it is successful. User ACL2 responds back with a token. The token is passed back through the client to the NPM auth WS, who takes your token and saves it into Redis, the great dictionary of keys and values. It will use this token in any instance where you need to access the registry again. Once it has done that, it passes the token back to Foyer. The door is open, and a hand slips out with the token attached. Registry client takes it, walks it back to you. Grabs your hand, and you transport back to Fastly, and then back to terminal point. Your token is written in your npm-rc file. You are now logged in. Book 3, Chapter 1. Now that you are logged in, it's time to install. You look around and are surrounded by nothing. Terminal point is empty with the exception of you and the CLI. Your mouth starts making a sound like it had made 1,000 times before. npm init -- yes. You're not sure where that came from or where you'd heard it, if you'd ever heard it. But there it was. And now in front of you is a package JSON file. You look at the CLI once again and say, npm install express. Shishigami arrives and looks around. Seeing no node modules folder and no package lock.json, Shishigami whistles, and Pacote arrives, carrying Kakash over her shoulder, or in her hand in this picture. They speak quietly. The address is registry.npmjs.org/express. Pacote grabs your hand and you disappear again, back to Fastly. Book 3, Chapter 2. I should have just paused and smiled there. That would have been really useful. Instead of like my mouth open in all those pictures, I'm super photogenic. Chapter 3, Chapter 2. Once again, you walk up to the shopkeep, and Pacote speaks. Check my accept header. Ah, I see you're here for the corgi for an unscoped package. Excellent. Go along. You remember from before that a corgi is a metadata file for the package requested. It's significantly smaller than your standard JSON representation of the package, and it includes dist tags, version numbers, and each version's dependencies. Since the package is unscoped, it is a public package, so there's no security to worry about. You have read access. Fastly sends you to a specific address in the Cave of Wonders. You arrive at the Cave of Wonders, an Nginx-fronted package server that is the home of packages and their information, served right from the disk. Who disturbs my... Oh, hello, what do you need? We're here for a corgi of this unscoped package. Here's the address. Very well, go right along. You get your corgi. And take it back to Fastly, who then caches it for quicker retrieval the next time it is needed. After that, you head back to terminal point. Once arriving, you and Pacote hand over the corgi doc to Shishigami, who reads it and then sends the two of you back for the corgi of each dependency. This occurs until all of the corgi docs are retrieved. Once Shishigami has all of the docs necessary, it produces a dependency tree. Ta-da! You have gained a dependency tree. Man, that was loud. Now that you have your dependency tree, the tool begins glowing again. It calls upon Pacote to get the packages. Pacote sees the versions and packages needed and uses those to create new routes to request. This time, it's TGZ files, or tarballs. Pacote checks inside of her bag. It's empty. She pulls out Make Fetch Happen, says a few words, grabs your hand, and once again, you're on the road to Fastly. It just so happens that tarballs are Fastly's specialty. Exciting. Pacote walks up to Fastly. It says here that I need to reach this very long address that I'm not going to say. Oh, let me see if it's in my cache. It is. Here you are. Thanks. That was faster than expected. You see, Fastly's caching system stores cacheable tarballs at its points all across the globe. This means that public packages that have been downloaded by other users can be saved after they are retrieved from the package servers. This makes for an extremely quick experience. You're probably downloading from that one that's in Sao Paulo. I mean, good God, if you're not, that's a problem. Pacote's make fetch again stores, or make fetch happen again stores the package away for you in Kakash, just in case you need it. And on to the next dependency package, array flatten version 1.1.1, and back to Fastly you go. On the way, you ask Pacote, do you really need to make one round trip at a time? And Pacote laughs. Oh, dear developer, this is Node.js. I make all of these requests in parallel to the best of my ability, trying not to pin your processor. Trying. I'm walking through these serially for your learning benefit. You nod. It says here that I need to reach this heck of an address. Oh. This is certainly an unscoped package, so it's public, but this isn't in my cache. Let me send you along to the Cave of Wonders, to that specific file you are looking for. You see, the registry has caves and package servers in several different places on the globe. They're where the little caves are. In different AWS data centers. Unfortunately, the caves are not located in South America, so sorry for the slow installs. We'll work on that. So Fastly's location in Sao Paulo will actually forward you to a cave in US West, which is in Portland. You arrive at the cave. Who disturbs my... Oh, you again, what do you need? We're here for this specific unscoped package. Very well, go along. You grab the package and head back to Fastly, who asks if she can make a copy in case somebody else wants this later. Then you head back to Terminal Point. This continues through all of the public packages. Pacote checks Kakash, does not have the necessary package, heads to Fastly. She either has the package or not. If she sends you to the closest package, if not, she sends you to the closest package server and makes sure... I just got like click happy here. And make sure to cache the package on your way back. Once again, the packages have been downloaded. Pacote begins, or once each of the packages have been downloaded, Pacote begins the extraction. The tar balls are untarred and placed into the node modules directory to match the tree. The tool glows again and begins to run its lifecycle scripts. You hear a song sing the words. Pre-install, build, install, post-install, finalize, refresh package JSON. Your package JSON is changed. All of your files are properly placed and built, and they are now requirable from your project, and you can use them. The end? No. Book 4, Chapter 1. All things are peaceful again. You can move quickly and build your web application now that you have a framework in place. But you need another package. And this time, it's a private one for your organization. You pull out your trusty CLI and speak into it. npm install at fantasyworld/super secret code. Shishigami arises again and calls upon Pacote for you to get the corgi for your scoped package. You and Pacote head off to Fastly. Fastly asks what you were here for and notices that your corgi doc request is for a scoped package. Before you can say anything else, she opens the door and sends you to the next step on our quest, the Eye of Othen, to prove that you are really who this token says you are. Look forward, Chapter 2. Your journey takes you further toward getting your package, and the next step is the Eye of Othen. They say that you stare into the eye, and the eye stares back, showing you your true reflection, bestowing upon you the gift of your real identity. The eye's true name is Spyhole, and you come to it from Fastly. It wants the exact request that you came with, and it examines your headers. It cares for your authorization, your authorization header, your cookies, and your Fastly client IP headers. Since we are unable to bring a session cookie with which to feed the eye, it will have to look into your authorization header. An authorization header includes the scheme and the credentials being used. So for the eye, the scheme is bearer, and the credentials are the authentication token bestowed upon you when you logged in. If your credentials match the records that Spyhole keeps, it will gift you with the sigil of your house. You will no longer be questioned, and you will be sent along your way. Now, how does it check? Well, remember logging in? When your token was created, it was stored in a Redis instance that is now being referenced by Spyhole. As long as that token remains in Redis, it is valid to reference and can be used to get through Spyhole. The tokens that you've used are available here. We will never display the entire token, by the way. It's the last bit, so you can tell, so you can delete them if need be. Now that your token has been retrieved, it is set as the value on the response back to Fastly. It is a bearer header. That header is your sigil. You have successfully been authenticated. Congratulations. Book 4, Chapter 3. Now that you have been granted your house sigil, you return to the shopkeeper, Fastly. She recognizes your sigil and sees that you are who you say you are, and therefore know yourself. She checks her cache to see if there is an entry with a document and this sigil. It is not there. She opens the door to the path of the Cave of Wonders. This means that your response was seen by Fastly, your new header was recognized, and you've been forwarded to the package server. When you arrive at the Cave of Wonders and announce what your intentions are, you'll be confronted by Deadbolt, the guardian of authorization and protector of the cave. Deadbolt will check your sigil and either grant or forbid your access to the package that you seek. Tread carefully. Your journey in on the forwarded request with a header that was attached by Spyhole has reached the package server. Nginx checks the path for a scoped package and proxies your request through Deadbolt if it is, in order to see if you are authorized to read that package. In order to get this information, Deadbolt checks with the keeper of user authentication data, user auth cache. Book 4, Chapter 4. User auth cache serves a very specific purpose. Does this user have access to this package? If so, is it read or write access? If it does not know, it reaches out to the Synecdoche API to find out, which passes through to user ACL2. As mentioned earlier, user ACL2 is the true master of knowledge. It and Payments API hold the final say on all things. Since any writes in our system go through to user ACL2 and the Payments API, once the package and user relationship are cached, once the package and user relationship are cached, if anything that could affect the relationship happens, user ACL2 and Payments API set a value in a queue that is consumed by a mighty tool called the ACL invalidator, which proceeds to replace the data in user auth cache and simultaneously invalidates any caching of the document in Fastly. Today, the sun shines upon you. Nothing has been invalidated in the wrong way. Deadbolt returns with news from the keeper. You are allowed. Proceed to get your Corgi doc. Had user auth cache returned with bad news for Deadbolt, you would have received the mark of forbidden. Now that you have the pass from Deadbolt, it operates as a proxy for the Cave of Wonders. You go directly to get your Corgi doc. You turn around and head back through Fastly. She caches the package in such a way that only you can retrieve it. You go back to Terminal Point. Now that you have a pass from Deadbolt, it operates as a proxy for the Cave of Wonders. You go directly to get your Corgi doc. You turn around and head back through Fastly. She caches the package in such a way that only you can retrieve it. You go back to terminal point. By now, you have the hang of this. You have the metadata, and you have your tool of valor. You know the path. Now join pacote and follow the same route to get your packages. The same exact route. You just have a different address that you're getting. Instead of getting the corgi doc, you get packages the same way. And with your bravery, hero, you've once again opened the doors to the promised land of the NPM registry. Now the 8.7 million voices that call out for hope can once again appease their gods and their masters. That is until they overthrow both of them. Oh, this thing's just going to wait until that whole thing's done, isn't it? That's a really long animation. The end. Oh, Brazilians are dope as fuck. Thanks, buddy.